Good morning, everyone. Today we are going to discuss unfolding computational graphs. First, tell me what is a computational graph?
And Pratika, a computational graph is a visualization representation of how a mathematical computation happens step by step. It makes up of nodes and edges. The nodes are represent operation like addition, multiplication, or an activation function, and the edges represent the follow of data between these operations. For example, if we take a simple expression like z equal to express y, we can represent it using a computational graph where x and y as an input node and the addition operation is the under node and z is the output node. In deep learning, our model built using many such operations. So instead of writing everything one equation, we break into a smaller steps using computational graph.
Why do we use a computational graph?
So computational graphs, it is used in many applications because every neural network, it can be represented by as a computational graph because it contains multiple layers and each layer will be performing its operations. And for example, when we take this image classification model, the input image will be going through the computational layers, activation functions, and pooling layer and fully connected layer. So each of these steps can be represented as such as a steps which will be representing the computation graph. So also frameworks like TensorFlow and PyTorch are also used in computational graphing. So these frameworks helps in building the graph when we delete an image and when we use it to calculate the activation functions under weight and bias.
What is recurrent network?
Yes, ma'am, I am Kunal. A recurrent neural network is a type of neural network that is used for sequential data. Sequential data means where data order matters like sentence, time series, or audio signals. In a normal neural network, inputs are independent of each other, but in an RNN, each input depends on the previous input. This is because RNN something is called a hidden state. The hidden state acts like a memory. It stores information from previous time steps and passes it to the next step. So the network can be passed information while processing the new input. For example, if we take the sentence like she is reading a book, the meaning of each word depends on the previous words. RNN helps in understanding this sequence. RNN are widely used in applications like text production, speech recognition, and speech translation.
What is the purpose of unfolding in RNN?
Myself, Vasakumar. In RNN, usually represents model on the top structure. The output from the step is back to the set input. This loop shows that the network processes data separately. However, the loop representation is not very clear when we want to understand how the computation happens at each step. So we use the concept called outputting or unfolding. Unfolding means that takes the loop and expand into multiple steps over the time. Instead of showing the loop, we can draw same network complement times. For example, if we have inputs x1, x2, and x3, step 1, the network process x1 and x2 produce h1 output. At step 2, the process x2 along h1 produce h2. At step 3, it processes x1 and x2 and produce h3. So the loop becomes a chain structure.
Why do we need unfolding? Why not keep the loop?
We need unfolding mainly for training and understanding the model. When we loop, it's difficult to apply the back propagation because they cannot clearly see the sequence of the operation. When we unfold the network, we can convert into sequence layers. This allows us to apply a method called back propagation. Through the BPT, the method calculate the error, output propagates the backward through the one-time step. Unfolding also helps the visualizing how the hidden state change over time and how we each input affect the final output. Another important that is help to identify the problems like variational gradients and exploring variants which occur big sequence. So unfolding is necessary for both training and better understanding of RNA.
Finally, summarize the concept.
Now I'm going to summarize the concept of unfolding computation graph. So computational graph represents the data flow through the model step by step. And in RNNs, we'll be using the loops to handle the data sequential data. But to understand and train the model efficiently, we should convert this loop into an recurrent graph. Only then we can understand what inputs and outputs are flowing and how it's flowing and what are the laws. So unfolding helps us to visualize how the inputs are processed in the layers and how the hidden states carry the information and how the outputs are generated. And
Thank you, everyone. That's all about today's session. Thank you, everyone.
Thank you.